Yeah,
Yeah, now it's
okay.
good.
Okay, fine. Internet connection. Okay, so today just we'll discuss about the truss, or which is also known as pin jointed framework. Okay.
Enjoyed. Okay.
And for that thing, we will discuss about the compression and tension in the joints, and then we will
Okay.
solve using the method of joints and method of sections. Okay.
Okay. Okay.
So if you just mm, so if you just draw any structure, like suppose this end is your fixed end, then you have this kind of structure
Okay.
that you can call truss.
Okay.
Pin jointed, why? Because at all these points, at all these joints are pin joint.
Okay.
Okay.
Yeah.
So what we'll do, we will solve the truss problem for one question through which we'll learn how to solve. Okay.
Okay. Okay.
So take another one and join these things are okay. And at this point, suppose load is 80 kilonewton, and here suppose we have horizontal load of 50 kilonewton.
Mm.
And about the length, suppose this height is 1.5 millimeter, and here these things are equal. Suppose that's these lengths are 3 meter each.
Okay.
Okay. So
Okay.
just first, what we need to do, we need to do nomenclature of the joints. So suppose this is your A,
Yeah.
B, C, D, E, A, and G. Okay.
Okay. Okay.
So uh, what we need to find out here, we need to find out in truss that the load on each element. Like this one is one element, element one. Then
Mm.
this one is suppose element two. Here element three, element four.
Okay.
Okay. So
Okay.
in this way, total 5, 6, 7, 8, 9, 10, total 11 elements. Okay.
Okay.
So we need to find out what are the forces on these elements, and also we need to check if the forces are in compression or tension. Okay.
Okay. Okay.
So find the forces in the members and find its character. That means if it is in compression or tension. Okay.
Okay.
So first of all, for any section, what you need to do, if you just remove these two supports, what will happen? Instead of support A, you can
Mm.
put one
Reaction.
reaction VA this side and suppose your HA this side.
Okay.
Okay. Similarly at G also there will be VG. And what about HG?
HG. Yeah.
Uh, can you tell me if there will be any HG or not?
Yes.
Why?
Because that is roller support.
Yeah, that is roller support. That means what? It can it can move along the horizontal direction or X direction, right? So there will be no
Oh,
reaction then.
okay. Okay. So
If it is,
first one A was pin support.
yeah, A was pin support. So that's why at this
Okay.
point it can move horizontally and vertically.
Okay. Okay. Roller support. Yeah. Okay. Fine.
Okay.
Mm.
So these three are our initial unknowns.
Okay.
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 So how can you find these three values? You need to use that equilibrium equations, right?
Fx is yeah. Delta Fx is equal to 0. Delta Fi is equal to 0. Ma is equal to 0.
Actually, that is not called delta, that is summation.
Oh, summation.
Okay.
Okay.
And moment is equal to 0. So from this one, what we'll get?
H is equal to 0.
Not 0. Look, here we have a 50 kilonewton force horizontally.
Yeah.
So HA plus, because we have assumed that the direction of HA is this one. So
This one.
both the directions are same. So HA plus 50 is equal to 0.
Okay.
That means your HA is minus 50.
Minus 50.
Okay. Now
Yeah.
from Fy, what you will get?
From Fy, BA minus 80 is equal to 0.
And one VG is also there, no?
BG, yeah. Plus VG is equal to 0.
Okay. So VA plus VG is
80.
80. Now what will be the moments? So what we know for pin support, at pin support, we have moments 0,
Okay.
right?
Yeah.
At pin support, the moment is used to be 0.
0.
Also at roller support.
Okay.
Only at fixed support, we have some moment, right?
Yeah.
So moment is 0. So what will be moment at point A if you take?
Point A, it will be HV won't be there. 80 into 3 meter
Mm,
and VG into minus VG into 9 meter plus 50. That 50 also comes, right?
yeah.
Plus 50 into 9 meter.
Mm, okay. Okay, so that should be equal to 0,
Mm.
right?
That 50 into 9 meter or 1.5 meter?
Exactly. And there is one more error that things we'll discuss. That will be 1.5. Okay,
Okay.
good. You correct this one. Now one more error is there. Look at this 80 kilonewton force. This A to C, that is 3. Actually, that diagram is like that is at half,
Half of
that is
that's a
as half, and that is
1.5.
as half position. Okay.
Okay. Okay.
So that one also will be 18 to 1.5.
1.5.
So by solving this, we can calculate that VG, right?
Yeah.
Then by putting that VG here, we will get our
VA.
VA.
Yeah.
Okay. So do you have calculator with you?
Uh, no, sir.
Okay, whatever. We can do these calculations later. That is not
No,
mandatory
important.
things.
Okay.
So now what we can calculate, we know that the reactions HA, VA and VG. Okay.
Mm. Okay.
But what we need to find out that forces in these members, these 11 members,
Yeah.
right?
Yeah.
So for that we have two kinds of method.
Mm.
One is known as method of joints and another one is method of section. Okay. So we'll
Okay.
discuss first about the method of joints, then we'll discuss the method of section.
Okay.
Right?
Yeah.
So what are the joints? This
Uh,
A, B,
A,
C,
B,
D,
C.
E, F, G, these points, these are the joints, right?
Mm. Yeah.
So first of all, think about joint A. So for
Okay.
joint A, what we have, this HA force is there, this VA force is there, right?
Mm.
Also, for this AB section, there will be one force in that direction, AB. Suppose AB tries to elongate.
Mm.
So that is a direction for AB. Similarly, for AC also, that is a direction, right?
Okay. Yeah.
So actually, it may possible that its arrow may be in the opposite direction. That will calculate. If the value is negative, then that means the arrow will be in opposite direction. Okay.
Okay.
So in method of joints, so first of all, we are thinking about the joint A. So, so what you can check, your HA value is minus 50, first of all,
Mm.
right?
Yeah.
So we assume that our HA in this direction. So that means actually HA is in the opposite direction, right?
Oh, okay.
That means at positive direction, positive X direction, value of
Mm.
HA is minus 50. That means that is in
Opposite
minus X
direction.
direction or negative X
Yeah.
direction.
Yeah.
Okay.
Yeah.
But as initially we assume that HA in this direction, so we are taking this one only for
Okay.
point A.
Okay.
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 In this side we have VA. Now
Mm.
here, suppose that is that for AC, suppose it is FAC. Okay.
Okay. Okay.
And for that AB link or AB member, the force is FAB.
Okay.
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 So here, what are the values known? That HA and VA.
Mm.
HA and VA are known to us, right?
Mm. Yeah.
Also, we know this angle. How? Look, this is a triangle.
Okay.
Triangle of height 1.5 and the base is
3
3,
meter.
where these two angles are similar. So this is an isosceles triangle actually.
Okay.
So for this, so it is 1.5 and this half portion that is also 1.5, right?
Okay. Okay.
So for that you can calculate this theta,
Mm,
right?
yeah.
So what will be that sine theta?
1.5 by 1.5. Opposite by hypotenuse.
Yes, if that is theta, now this is your 90-degree angle, right?
Yeah. Yeah.
So we know what values, that is 1.5 and that is 1.5. Okay.
Mm,
So better if we do tan theta.
mm,
Tan theta means that height divided by base, right?
yeah.
So both are same. That means your theta will be pi by 4 or
Okay.
45 degrees, right?
Mm, okay.
Okay. So if you just put the value here, that is 45 degree. So
Mm,
now what you can do, take the components of FAB in vertical and horizontal direction.
mm.
So in horizontal direction, what is the total force? That is HA
HA plus
plus
FAC
FAC
plus
plus
FAB cos 45.
FAB cos 45. And what is the forces in the horizontal vertical direction?
VA
VA
plus FAB sin 45.
FAB sin 45. So at equilibrium, what will happen? At each and every joint,
Mm,
that will be in equilibrium.
okay.
Okay. So your this summation of fx that should be equal to 0. That summation
Okay.
of fy that should be equal to 0. So
Okay.
from here you can calculate FAB because you know VA.
Okay. Yeah.
By putting that FAB and HA, you can calculate FAC,
FAC. Yeah.
right?
Yeah.
So these two value you know. So that
Mm,
means the forces in the member 1 and 2 you have calculated.
mm,
Okay.
yeah.
Now similarly, if you think about point B,
Mm,
just roughly we'll do that. For point B, what will happen? Okay, before that,
mm,
okay, we'll do that for point B, then we'll discuss. So for point B, 180 kilonewton force is there, right?
mm, yeah.
Now from point A, what we have chosen? That AB in this direction, right?
Yeah.
So from B, for this member, this one will be the direction, that
Okay.
opposite one. Okay.
Okay.
So this one is your FAB.
AB.
Okay.
Mm,
Now these two are the unknowns.
mm, yeah.
What happened? So that is 80. Now suppose this is your direction of FBD and here this is the direction of FBC. Okay.
Okay. Okay.
So now for this also you can check if this angle is 45, that is 45. Similarly, for this triangle also you can check that these angles are 45.
Mm,
Okay.
okay.
You will get that. So what will happen if this angle is 45? Similarly, you can do for this point B that summation of fx is equal to 0, then summation of fy is equal to 0,
Okay.
right?
Yeah.
So by doing this, what you will get here, that 8 is given, FAB you have calculated for point A. From point A,
Mm.
you have calculated this FAB, right?
Yeah.
So what are the unknowns? FBD and
FBD
FBC.
and FBC.
And you have two equations, so you can solve this,
Okay.
right?
Yeah.
Like in your practice problem, there has some questions like this. There are some forces in this direction. Then two values are given and angles are given. So what are the other two values? This kind of questions were there, right?
That was in the first class questions, right?
Uh, that first
But
class
that
question.
I haven't done. So I have only done the second class questions.
Okay, but do the first class questions also, so that it
Okay.
will be better to understand these trust problems.
Okay.
Like you
Okay,
have
sir.
two equations and two unknowns, so you can calculate.
Okay.
Okay.
Yeah.
So in the similar way, you can find out from all the joints, if you
Mm,
take the directions of forces and then just solve. So you can calculate for all the 11 joints. Okay. Sorry, for all
okay.
the 11 members, you can find out the force.
Okay.
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 Now, what we need to find out, we need to find out its character, if it
Mm,
is in compression or tension. Okay.
mm, yeah.
So from here itself, what we can check, suppose you got your VA positive.
Mm,
Okay. So by
yeah.
solving this, what you will get, your FAB will be negative. If your VA is positive, that means what? FAB is
Negative.
minus VA by sine 45.
Mm, yeah.
So your FAB will be negative value, right?
Okay. Yeah.
Now look at your FAB. So FAB was, if this is your point joint A, so it is going out from your joint A,
Joint. Yeah.
to our assumptions, right?
Mm,
But
yeah.
if it is negative, that means it is
It is
coming
actually going towards C.
towards the joint A,
Mm,
right? So
yeah.
this is our assumptions, but this is the actual one we got after doing the calculation. Okay,
Okay. Okay.
so it is coming to the towards the joint. That means it is compressing the joint.
Okay.
It is forcing that joint
Mm,
to means to compress, right?
it is
So
compression.
that will be compression.
Compression.
So towards the joint, that is compression,
Compression. Away from the joint is tension.
and away from joint,
Tension.
that is tension.
Okay.
Okay. So that is the
Okay.
character. So for this question, you can calculate all the forces in all the members
Mm,
and their characters. So you will do it. You will do
mm,
it later by your own. Okay.
okay. Okay. Okay,
Using
sir.
method of joint. Also, you will do it using method of section. So we will learn that method of section now.
Okay.
So just you need to do one question, that is enough from trust.
Okay.
And if
Okay.
you solve this question,
Mm,
then these kind of things you will get. So practice problem of our first class, that is
mm,
also to done through it, right?
okay. Okay. Yeah.
So now what we'll do, we'll learn about the method of section.
Section.
Okay. So like
Yeah.
for method of joint and method of section, for both the cases, what is our initial step? our initial step to find out the reaction at A and G. That is our initial step.
Okay.
Okay. After finding that VA, HA, and VG, then
Mm.
we need to use this method of joint and method of section.
Mm.
Okay.
Okay.
So now we'll discuss about the method of section. So in method of section, what will happen? This was your point A, it is point B, it is point C.
Mm.
Then B, C, D, E, F, G. That is your total structure, right?
Yeah.
So in method of section, what you need to do? You need to cut the section.
Okay.
Okay. Now how can you cut? So you need to cut such a way in which you will get only two unknowns. So cut
Mm.
in such a way that
Mm.
there is only two
Two
unknown. Okay.
Mm. Okay.
Or it, not two, three unknown. Maximum three unknown, then it's fine. Okay.
Mm.
So first of all, at point A, you know that VA and HA, right?
Yeah.
At point G, you have VG. At B,
Mm.
you have that 80 kilonewton force, and here a 50 kilonewton force. Okay.
Mm. Yeah.
So first of all, you will cut. So if you cut from here, what will happen?
Mm.
This is the only thing remaining, right?
Yeah.
So for this one, you know that HA and
Mm.
VA at point A. And these two are there. So for these two, there will be two forces. So that is FAB and FAC. Okay.
Okay.
So you can check this diagram is completely same with our uh, with our uh,
Um.
joint A for method of joint.
Okay.
In method of joint check, we got exactly this similar
Mm. Oh.
FBD. This one.
Mm.
So
Yeah.
so you can solve this one. From here you can find out your FAB and FAC,
Okay.
right?
Yeah.
Now what we'll do, you don't need to cut from here. Means after cutting from here, you get these two values. Now leave this part, cut from here.
Okay.
Okay. So
Yeah.
for that, what will happen? So this is your point A. At point A, you know these two value. This is your point B, where you have this 80 kilonewton force. You have cut through this line. So this one is one unknown here and
Mm.
one, that is one unknown, and
Mm.
here another one, right?
Okay. Yeah.
So for this section, what you can do here, if it is your force FAC, suppose this is your FBC and this is your FBD, right?
Yeah.
So for this whole section, now look, we haven't mentioned that if AB. Why? Because that is not cut it part now. That is not cut
Mm,
here. We have cut through
that portion.
section. Suppose this is our section 1 dash. This is our section 2 dash. Suppose. So when we have cut through section 2 dash,
Mm,
these three portions are opening, right?
mm. Okay.
So there has nothing changed in member AB. So for
Mm,
AB, we don't need to show any kind of FAB. Because look, if you show one FAB from this side also, you need to show another one. So that two vanishes each other.
mm.
Right.
Okay.
So now for this whole section,
Mm,
now for the whole section, if you find out your summation of fx equal to 0 and summation of f is equal to 0, you can calculate these two values because these three values are known. Also, FAC you have calculated from here.
mm.
Okay.
Okay.
Suppose you didn't calculate FAC from here. So here you have total three unknowns, right?
Yeah.
So one equation is summation of f is equal to 0, another one is Fi is equal to 0, and another one will be moment at any joint at A or at
Mm.
B that is equal to 0.
0.
Now can you tell me at which point we'll find out the moment? At point A or point B
Mm. At point A.
or point B?
Mm. Both the points are having moment
Yeah, at
0,
both
right?
the points that will be 0. But actually when we will do the calculation, then we'll get we then you will understand these things.
Mm.
Suppose you are find out moment at point A.
Mm.
So like at both the points you find moment, that is fine. You have one, two,
2,
three
3.
equation and three unknowns. So that is fine. You can solve. But
Mm.
to make easier for the calculation part, if you find out moment at A, what will happen? Moment will come due to these three forces,
Yeah.
right?
Yeah.
So you can check that there you have two unknowns in one equation,
Mm.
right?
Yeah.
But if you find out moment at point B,
B.
for moment at point B, moment will come due to these three forces.
Yeah.
So from here in this equation, there is only one unknown,
Mm. Yeah.
right? So it will be easier to calculate. That's it. Otherwise, you can find out moment at A. That's fine.
Oh, okay.
Okay. So that is the method of section. So from here you can find out these three forces. From here
Mm.
you can get these two
Now,
forces.
how do we know where to take the section?
Any places. That is the only condition for that. Cut in such a way, like you can cut from here itself.
Okay.
Suppose in your question,
Mm.
uh, suppose in your question it is mentioned that find out
Mm.
the forces in the members DF, DE and CE. Okay.
Mm.
Actually, uh, we are going to solve for all the members, but
Mm.
it's not supposed to, like in your question paper, it will not ask to find out the values at all the members. So there will
Mm.
be some members will be mentioned. Okay.
Okay. Okay.
So we need to find out the forces in the members DF, D, C. So
Okay.
look, that is your DF, that
Mm,
is your D, that is your
mm,
C, right?
mm. Yeah.
So if we cut through this section, so take this from this end or from this end, whatever.
Mm, mm,
So if you choose from this end, what will happen? So here, first of all, you have that point E,
mm.
that that is F, E, F, G. So that is your F. Here it is E, here it is G. Now look at the forces. Here one vertical force at point F, there is one horizontal force, right?
Yeah.
So horizontal one, here vertical one. What are the another forces? That is this one, DF.
Mm,
For the member DF, you will get, suppose we were assuming the direction is this one from F. So that is FDF, right?
yeah.
Then from E, we have that FC and FDE.
Okay.
So FC and there is FDE. Now the angle you know because the values are given, right?
Mm,
So
yeah.
for this whole section now, if we use the equilibrium equations,
Mm,
these three equations, so using these three equations, you can find out that you have one, two, three unknowns.
okay.
So three unknowns you can calculate directly, right?
Okay. Yeah.
So that's why method of section is uh, will give you the answer in shortest time
Mm,
compared to method of joints. Like for method of joints, what you need to do to find if you want to find out for these three values. So for that, what you need to take at point E and point F, you can choose if you
mm,
use method of joint, right?
mm, mm.
So if you choose point F, so for that, this DF is there, EF is there, EG is there, right?
Mm,
And here one 50 kilonewton force is there, right?
yeah. Yeah.
So now check here you have total one, two,
One, two,
three unknown.
yeah.
But in case of method of joint, you would find out at one joint only. So you can't use the moment equal to zero because actually moment is zero, but you
Mm,
will not get any equation. That will be zero
mm,
equal to zero
mm,
as all the forces are passing through these points only, right?
yeah. Yeah.
So you have two equations, summation of fx equal to zero and summation of y equal to zero. But you have total
Okay.
three unknowns. So you can
Three
calculate
unknowns.
directly. So for that, what you need to do first, you need to do for point G. For point
Okay.
G, one force this side, another force this side, this one.
Mm,
So from here, you will get this Fg. Then you need to
mm,
put it here. Then from here, you can calculate these two.
okay.
Okay, that's why method of
Okay.
section is more important than method of joints.
Okay.
So what we will do, we will solve this question for all
Mm,
the members
okay.
using both the method of joints and method of sections. Right? That will be a good practice.
Okay.
Okay. Now
Okay.
there is some shortcuts thing for truss that we will discuss now.
Mm,
Suppose uh, hmm, okay. Hmm, Okay, we can draw this one also. No problem in that. Okay, can you, so just suppose this is your joint A, B, C, D, E, F. Okay.
Okay.
Mm. Now suppose at point B we have a load of 50 or load of F. Okay, F is
Mm,
point here, 1 point. So suppose load is P. Okay,
mm,
that is C. So now what are our members? That is suppose 1, 2, 3, 4, 5, 6, 7, 8. Total 8 members are here, right?
yeah.
So can you tell me what will be the forces in the member DF and that EF?
Mm,
That is your joint F.
mm. The value of the forces.
Yeah, what will be the value of the forces FDF and FDEF?
Um, I don't know. Sir. Uh, but there is no forces specified given, right? The values like B's value, nothing is given, right?
Yeah, that you can suppose that is okay. That you can
Yeah.
suppose 50, whatever.
Okay.
Actually, you just think about this joint F. That is also a pin joint,
Yeah.
right?
Yeah.
So at this point, what will happen? At point F, your summation of Fx should be 0 and summation of Fy should be 0,
Yeah.
right? Now, if
Yeah.
we find out, suppose this the angle is also not given, suppose that is angle theta.
Mm.
So if it is angle theta, then what will happen? Summation of fx is,
If DF will be 0,
and what will be fef?
if EF will be FEF into sine theta, FEF sine theta is equal to 0. So FEF will be also 0.
Yes, perfect. So your f, df and fef both are
0.
0, right?
Okay.
So that
Yeah.
is one shortcut thing. Like, look, if if two members are parallel
Okay.
from a point, in that case, what will happen? If there is no other force, suppose F point, that is two force member only.
Okay.
Okay. So for the
Mm.
two force member, if these two things are parallel, then
Mm.
these two values will be same.
Okay.
Okay. Otherwise, 0. Like if it is not parallel, any kind of thing, then both the values will be 0.
0.
Okay. So for a two
Okay.
force, not member, for a two force joint, for a two force joint, if these two things are parallel, then these
Mm.
two values will be same.
Mm.
And if they are not parallel, then
Mm.
both the
0.
values will be 0. Okay.
Okay. Okay.
Now from this concept itself, suppose this is your joint A. In this direction you have one force, in this direction you have one force, and here
Mm.
you have another one. So suppose this is F1, this is F2, this is your F3. This is one your pin joint. So can you tell me what will be the value of F3?
this is not a two force joint, right? This is three force joint.
Yeah, that is three force joint.
Okay. Um, F1 will be equal to F2.
Okay. And what will be F3?
Mm, so we will take the equilibrium equations.
Yes.
So
Perfect.
um, F1 minus F3 cos theta will be equal to 0, and F3 sin theta will be equal to 0. So F3 is equal to 0.
That means your F3 is equal to 0.
0.
Right.
Yeah.
So for a three force joint, if
Mm.
two forces are parallel,
Oh,
then these two values will be equal. And the third
okay.
one, what will be whatever is the direction, that
Okay.
will be 0. If it was a perpendicular also, then also the value will be 0.
Okay.
Like you, like what will happen if it is perpendicular? That means what? Same concept, that summation of fy, that is f33 is equal to 0. Right.
Mm.
Only if this f3 is also parallel to f1 and f2, then we'll get one equation. Right.
Yeah.
Otherwise, that is equal to 0. So just for this thing, suppose that is not our P force, we have P force in this direction. So we have already found out that, just 1 minute. Okay. So for this truss, we have find out this, these two values are 0, right? Hello? Hello?
Hello.
Yeah, so for this truss, we have calculated that the forces at member 7 and 8 are 0, right?
Yeah.
Now, if these two are 0, just you can, when you are going to find out the forces, you can eliminate these parts, right?
Yeah.
Now, so this one is the remaining section. So just eliminate this overall part. So now check if this was is gone, then
Mm.
the member 5 and 6. These two are
Mm.
also, they are also not
Mm.
parallel. So this one, this should 2 will also be 0, right?
Okay.
Because they are not parallel. This is the only concept to be
Oh,
some values, right? Right.
okay. Yeah.
So if these two eliminates, then what will be about 4? About point D, there is nothing. So that one also eliminate,
Mm.
right?
Yeah. Yeah.
So in that whole portion, there will be no forces.
No forces.
Okay, so
Okay.
that will be, they are known as zero force member.
Okay.
So if it is asked in your paper that find out
Mm.
the forces in member 4, suppose, then you can calculate from these things that the force in member 4 will be 0, right?
Yeah. Yeah. Yeah.
Now for
Okay.
this section, look,
Mm,
that P
mm,
force is that is parallel to that FAB, right?
uh-huh.
So this force in this member 3, that will be 0 also, right?
Yeah.
So this one is also gone. Now
Mm,
if this is gone, check here at point C, there has
mm,
only two forces, right?
mm,
So you will get these values also 0 and this one is also 0, right?
mm. Okay.
So you will get things at point A only.
Point A.
Okay. Actually, this whatever the truss we have drawn, that one is not validate one. Like
Mm,
nothing can be done only at point one, only one point.
mm.
Okay. But that is
Okay.
the that we have discussed to know these concepts. Actually, there may
Okay.
be one problem like here you have one joint, here you have another joint. Then it is gone in this way. Okay.
Mm, okay.
Here one force is there. So for this section also you can find out these things are not parallel. So this is 0, these two are 0, then these two are 0, these two are 0, similar in similar conditions. Right.
Mm, mm.
So you can find out all these things are 0, but here you have P force. So here also you have P. Similarly, here also you will get P. Similarly, P here. So at these things you will get P and other things you will get 0. Okay.
Okay.
So that is the concept for trust. So what we will do, we will solve this question for
Mm,
using both the methods. So your concept will be clear after that, and then solve
mm.
1 to 2 more question on trust. So that is enough.
Okay.
Okay, that is enough for trust.
Mm,
And with that, just if you complete these things with that, what will happen? That
mm.
static part actually we are done.
Okay.
Actually, what means that uh, what is static, then what are the equilibrium equations, then reaction and support and loading,
Mm,
then that pin jointed framework, compression, tension, and that method of joint and method of section. Then
mm.
also you can check that you have one more thing, that is frames and machines.
Huh.
Okay,
Yeah.
so frames and machines, that are nothing, that are that extended portion of truss,
Okay.
that is uh, extended portion. Like how you can check for a truss. Suppose
Mm,
you check, you assume the truss in this way. Okay.
okay.
Now, if assuming a machine or a frame part, suppose it is given that this end is fixed. From here you have one more arm. Then from here you have one arm in this way. Then suppose one arm this way, and at this point it is having a roller end. This one.
O- Okay.
So just there are some changes and difficulties in drawing, but the basic
Oh,
concept is same. That you need
okay.
to find out the first you need to find out the reactions.
Mm,
So if we just write here, So your first step is to find out the reactions.
Reactions.
And what is the second step?
Equilibrium equations.
Equilibrium equations. Like how can you find out the reactions? That is using equilibrium equation
Mm,
for the
Support.
at support you will find out the reaction, but you need to use the equilibrium for the overall body or overall
Oh,
structure,
okay.
right?
Yeah.
And then using the in the second step, if you use the method of joint, then you need to find out the equilibrium equation or summation of means the two equations at
Mm,
all joints. By this you can find out the forces at each member. That is your method of joint.
mm,
And using method of section, you need to find out the equilibrium equations, these three equilibrium equations at the
mm,
joints.
mm,
Okay.
okay.
Like this one. Okay.
Okay.
So that's the thing. So with this, we can complete this static portion. After that,
Okay.
what we will do, we will learn about
Mm,
the properties of material, then stress, strain, all these things.
mm,
Okay, yes. Up
okay.
to this
Okay.
point, you can understand that uh,
Mm,
for a member, you calculate for a member, you give some,
mm,
suppose you are giving some forces that is tensile force. When it will be in
mm.
tension, when it is away from the
Point.
joints.
The joints.
Okay. So away
Okay.
from the joint, so that is some force. Also, if it is towards the joint, that is in
Compression.
compression force. So for
Mm,
these forces, what will be the changes in the material or in that member, that we will learn, and how these changes occurs, what are the properties for this. I mean, these things are depends on the properties of that material. So these things we'll discuss in the next class. Okay.
okay.
So
Okay.
till now, what you will do, you will just practice this trust problem, this
Mm.
question using both
Method
the
of joints
methods.
and method of sections.
Yeah, then and just try to solve one or two more questions. That is enough
Oh,
for trust. Trust is
yeah.
a very easy thing.
Okay.
Okay. And I
Okay.
will share these things with you. So don't need to worry.
Okay, sir.
Okay. Then okay, we are binding up for now then.
Okay, sir.
Okay. Thank you.
Okay. Thank you so much, sir.